Okay, chapter 11, day 1. We're going to focus on how do we graph trig functions now. So now we're going to look at the graphs of trig functions. So we're going to have to start with understanding how a trig function is laid out, what are the different parts of it, and what do the different numbers mean as we do it. So let's take a look. So the general trig function is laid out like this. Y equals, or I might say fx equals, some number a, and then you'll have either sine, cosine, or tangent for now, okay? And then you'll have some number b, and then x, or, okay, you have an x, plus some number c. You might not have a c there sometimes, but if you do, you'll have a number c. It could be positive or negative, but you'll have a number c. Now, each part is, the first part A is what we call the amplitude, and we'll define these in a minute. The second part is what we call the frequency. And the last part is where our center line is. And we've seen this before with other functions. The tack on at the end shifts the graph up or down, whether it's a positive add-on or a minus add-on, okay? So we've dealt with center line shifts before, all right, by shifting our graphs up and down. But the amplitude and frequency are a little bit new for us. So let's define this. Amplitude is how high or low the graph is from the center line. So from the center line up or from the center line down, that's our amplitude. It is always positive. So even if the function is a negative function, the amplitude is always positive. All right. So for example, if I give you a graph of a sine curve, okay, the amplitude is this distance here from the center line, okay, this C with the L means center line, up, there's our amplitude, okay? If you want to calculate it numerically, if you take the difference between the max and the min and take half the difference, you'll have the value of the amplitude, all right? Frequency. If I said, how frequent do you go to the store? It's like, how many times does that happen? It's the same thing here with trig functions. Frequency is how many graphs, how many complete cycles of the graph are created in a span of 0 to 360 if we're working in degrees, or 2 pi if we're working in radians. So how many complete graphs do we get? So for example, here's one that I drew. I started at the 0 line, and I went up to a maximum, down to a minimum, and back up. That's one complete graph. But this one that I made kept going, and at 360, look, I had one full graph and a half of a graph. So if this was the picture that I did, my frequency would have been 1.5. It's how many complete graphs are from 0 to 360. All right, in this case, I got 1.5. All right? Now, period. The period is the number of degrees or radians it takes to make exactly one complete cycle. So how long does it take for a complete cycle is called the period. So here's a graph that I drew. Started at maximum, dropped down, came back up, ended at maximum. The period would be how long it takes to go from the beginning to the end of one complete cycle. For the graph that I drew, I said it took all the way to pi over 2, okay, measuring in radians. So the period for this graph would be pi over 2, okay? The period and frequency are related to each other, all right? They're related to each other. The frequency is, again, 2 pi, which is one full trip around, okay? 2 pi or 360 divided by the period, all right? If I take how many I make in this within 2 pi, or how long it takes, 2 pi divided by how long it takes will tell me how many I get to do. So frequency is 2 pi over the period, or if we're in degrees, frequency is 360 over the period, okay? Now, period, on the other hand, if I multiply both sides by period and divide by frequency, period is 2 pi over frequency, or period is 360 divided by frequency. These little formulas are the ones that you're going to have to know. Okay? Center line is exactly what it says. It is the center of the graph. So it's halfway between the max and the min. All right? So to calculate it numerically, we take half of the max plus the min. We're taking the average, okay, of those two values. So if this graph starts down here, for example, and heads up and down, and then up and down, halfway between is my center line. All right? So that's just the definition of center line. What you're going to have to be able to do is you're going to have to be able to graph some. So for example, the problem might say, graph the following function, y equals 3 sine 2x plus 1, and graph it from 0 to 360. So automatically I know I'm graphing in degrees, all right? This tells me degrees. So I have to think of all of my relationships in terms of 360, not 2 pi for this problem. So, a couple things. I have to identify amplitude, frequency, period, and center line before I start. Amplitude is this number right here, so my amplitude is 3. Frequency is that number right there, it's 2. The period, I got to calculate. Center line, up 1. Okay? The period, again, is by the formula we had before, is 2 pi over the frequency, or the period is 360 over the frequency. And since we're measuring in degrees, we're going to use 360 divided by my frequency of 2, okay? So this number right here goes right there. And 360 divided by 2 is 180. So the period is 180 degrees. So I have to identify this before we start. Now, we're going to make an axis. All right? And now we start. Okay. So first of all, keep in mind, sine starts on the center line, because at 0 degrees, sine has a value of 0. Cosine starts at the maximum or a minimum if this is negative, and we'll talk about that later, but cosine starts at max or min because the cosine of 0 degrees is 1, and that's the maximum our values can take on. So let's follow this process. First, draw the center line and make it dotted. So our center line is up 1. So I'm going to go up 1 here, and I'm going to put my center line in. I'm going to make it dotted. And I'm going to label it center line. Okay? Put a dot where the graph starts. So put a dot where the graph starts. Well, we have a sine graph. Sine starts on the center line. So this graph is going to start right here, because that's my center line, and this is 0 degrees. Okay? All right, so this is 0. Now, decide if the graph goes up or down first. Well, how do we decide? I have to take a look at the sign in front of the 3. This is a positive 3. And so for sine graphs, positive sine graphs head upward first. Upward. Negative sine graphs head downward first. Okay? Cosine graphs. If it's a positive cos, it starts at a max and heads downward. Starts at max and goes downward. If it's a negative cos, starts at a minimum and heads upward. I know this sounds like a lot, but after we draw a few, you're going to get the hang of it. So starts at minimum, goes up first. So we have a sine graph that's positive. So we start at the center line, we head upward first. Okay. Decide if the graph goes up or down. So we're going to head upward. Draw one complete cycle, which is 5 dots on this graph. Draw one complete cycle. So a sine graph is going to head upward first, all right? Because if we follow the circle around, okay, basically we're following around our unit circle here, all right? As we head upward to 90 degrees, the sine value, the y value, gets larger, okay? So we put 5 dots on, all right? Now, our amplitude is 3, so I got to go 3 above my center line. 1, 2, 3. So from here I head upward, I make a dot. Okay? Now, I head downward because the sine value gets lower and lower and lower until I get back to the center line, and that's another dot. Now we go under the center line because we're negative until we go to the minimum. So 3 under. So from here I go 1. No, that was 1. Oops, sorry. 1, 2, 3. So it's not quite to scale. So I go downward. Okay. And then from here, I go back to the 0, back to the center line, I go upward. So I put center line, max, center line, min, center line. That's 5 dots, and now I can connect them rounded, not pointy. I've drawn 5 dots, center line, max, center line, min, center line. Okay? So draw one cycle, 5 dots. Label the axis the value of one period. So right here's my axis. So right on this x-axis, right where this ended, I'm going to label it the value of the period, which we know is 180 degrees. 180 degrees. So there's my label. Okay. Check the graphing domain, which is in the directions, and see if I need to go further or if I'm done. So let's check. Check the graphing domain in the directions to see if you're done. Well, in the directions, it said I had to graph all the way to 360. I graphed only to 180. So what do I have to do to get to 360? I'm going to have to do this again. So here we go. Starting here, this is my first dot. 1, and then I go max, center line, min, center line. I'm going to move this one over just a little. Minimum, center line. So I'm here, do this one more time. That brings me to 360. So now I have graphed an amplitude of 3, 1, 2, 3, and then 1, 2, 3. I know it's not quite to scale. I have a period of 180, because that's when one complete cycle back to the center line hit again. And I graphed all the way to 360 because it told me I had to go to 360. So we're going to practice graphing in class. That's it.